Good morning, everyone. Welcome to our math class today. Joining me today is Isabel, and I think the rest of you can join because we don't have electricity. But I'll record lesson 4.5. It's about multiplication and division of radicals. To start with, let's recite today's memory verse. It's found in Luke 6, verse 29. And again, it's still about radical love. To the one who strikes you on the cheek, offer the other also. And from one who takes away your cloak, do not withhold your tunic either. Our MBC Boosters is about radical love through a Bible verse. So aside from our memory verse, you will write a Bible verse that reminds us how to show radical love to others. Now, at the end of this lesson, you'll be able to perform multiplication and division of radical expressions. So just like the title says, we will multiply and divide radical expressions. Now, let's start with this triangular garden. A triangular plot is 30 with a square root of 3 feet in height and a base of 15 square root of 3 feet. How many plants can be planted in a triangular plot if the nursery suggests 4 plants per square foot? If you have your answers, you can post it in our Telegram group chat, and the first one to get the correct answer will get today's bonus points. Now, how do we multiply radicals? Rule number 1. If the radicals have the same indices, then you can multiply their radicands. Example, square root of n, that's square root of n. So we have the same index, so we simply multiply the radicands, a times b. That's square root of n, ab. Ma'am, what will happen if there is a number outside? Like example, 5 square root of 2 times 4 square root of 3. What will you do with that? You multiply the whole numbers outside. 5 times 4 is 20. Same index, right? 2. So square root. Then multiply the radicands inside. 2 times 3. So we have 6. Our answer is 20 square root of 6. Let's have the first example. Multiply the following radicals. It's similar to what I showed you a while ago. We multiply the whole numbers. 2 times 3. That's 6. Same index. So you copy the radical sign with the index. Then 7 times 8. 7 times 8 is 56. So 6 square root of 6. But we need to simplify square roots of 56. Remember, 56 can be written as 4. 4 times 16 times 14. So we can write 6 square root of 4 times 14. Then we need to simplify that. How to do it? So what's the square root of 4? That's 2, right? So we let 2 go outside. Next, square root of 14. You could no longer simplify that. So you just write square root of 14. Let's simplify. 6 times 2 is 12. Copy square root of 14. So the answer is 12 square root of 14. Now let's go to the next one. Ready? 2 Square root of 2x times square root of x plus 3. Now, we check their index. Do they have the same indices? Yes. Remember, if you could not see the index, it means the index is 2. Same index, so we can write them under one radical sign. So 2x, that's for the first one, and the second one is x plus 3. Let us multiply them, the radicands inside. 2x times x, that's 2x squared. 2x times 3, that's plus 6x. Now, ma'am, can I simplify it like this one first and the one next? No, you can only simplify it if it's in one factor. So this is now our final answer. For example, to give an example, this one, 4x squared. The square root of 4 is 2. The square root of x squared is x. So the answer is 2x. But if you have like this, 4 plus x squared, you could not let 4 go outside first, then x squared go outside next. And the answer is 2 plus x. No, that is wrong. This must be in one factor first before you can let that go out. Next one, quotient. Now the same with the product. If two radicals have the same indices, like both are square roots or both are cube roots, then you can write them in one radical expression. Remember, our denominator must never be equal to 0. Let's take the first example. Ready? Now this one. First, you look at their indices. That's 6 and 6. So they are of the same indices. So we can write them under one radical sign with an index of 6. So we have 64 r to the 7th over r. The next one, let's simplify the one inside. Remember the rule for this? Same basis for division, we subtract the exponents. So 7 minus 1, that's r, 7 minus 1. So we have r to the power of 6. Let's write it. How about 64? How can we write 64 in a base with an exponent of 6? 64 can be written as 2 to the power of 6. So let's rewrite it. 2 to the power of 6, r to the power of 6. Let's find the 6th root. It means we divide all exponents by 6. Let's start with 2. 2 to the power of 6, the exponent divided by 6, the answer is 1. So it goes out. 2 to the power of 1. You may not write it. Next, for r, let's look at the exponent. 6 divided by 6. That is 1. So our answer is r to the power of 1. Again, when the exponent is 1, it's okay not to write it. Our final answer is 2r. Let's go to the next example. You look at this. They have the same index, square root and square root. So we can write them under one radical sign, 63 over 7. 63 divided by 7, is 9. What's the square root of 9? You have 3. Again, even if the answer is plus and minus 3, we just take the principal root. It means the positive one. What if the radicands have different indices? Now, here's how you will do it. The product of radicals with different indices but the same radicand. First is you need to write the radical expression into a rational exponent expression. The next one, we apply the product rule for exponents, like we add the same exponents. In step 3, we write it again into a single radical. And step 4, we simplify the radical. Example, number 1, same base. So we will same radicand 5, but their index is different. This is 2, the other is 3. So step number 1, we change it into a rational exponent form. That's 5 to the 1/2, and the other is 5 to the power of 1/3. Next, same base, add the exponents. So 5 to the power of 1/2 plus 1/3. Then we add the exponents in fraction form. That will be, I taught you right, it's shortcut, 3 times 1, 2 times 1, over 2 times 3, 6. So we have 5 to the power of 5 over 6. Then we rewrite it back to its radical form. 5, the numerator is the exponent, then the denominator is the index. This is now our answer. The 6th root of 5 to the 5th power. Or when we simplify 5 to the 5th power, that's 5 times 5 times 5 times 5 times 5. The answer is 6th root of 3,125. That's the final answer. Let's go to the next one. Ready? They have the same base. Their radicand is x. So we can rewrite it into a rational exponent form. Ready? X to the power of 1/3. And the other is x to the power of 4/5. This is the numerator. The index is the denominator. Then we will add the exponents. X to the power of 1/3 and x to the power of 4/5. Then let's add the exponents. Ready? 1/3 plus 4/5. 5 times 1 is 5. 3 times 4 is 12. Over 3 times 5 is 15. So our answer is x to the power of 17 over 15. Write it in radical expression. That's the 15th root denominator of x to the power of 17. Now, we can still simplify this. You look at the exponent. 17 divided by 15, that's 1. So x to the power of 1 outside. But there is a remainder. That's 1, remainder 2. So the remainder will be the exponent of the radicand inside. Our final answer is x 15th root of x squared. Now, how about for products of radicals with different indices and different radicands? Now, step 1, we change the expression from radical to rational. Next, step 2, we change the exponents into similar fractions. So you need to apply your LCD this time. Step 3, rewrite the product as a single radical. And step 4, simplify the radical. Let's start. Ready? Here. The first step is we rewrite it into a rational exponent. So we have 2 to the power of 1/3. How about for 3? 3 to the power of 1/2. Now, what do we do next? Here, you check the exponents 1/3 and 1/2. What is the LCD? The least common denominator. The least common denominator of 3 and 2 is 6, right? So we write 6 here. Now, what should we multiply to 1/3 to make it turn into a denominator with 6? That's 2, the denominator, and let's also multiply the numerator by the same number. So 2/2. So we have 1 times 2 is 2, 3 times 2 is 6. Check. How about for 1/2? What should be multiplied so the denominator will become 6? We multiply it by 3. So 3/3. 1 times 3 is 3. 2 times 3 is 6. Let's check. So let's rewrite now our exponents. It becomes 2 to the 2/6 power and 3 to the 3/6 power. Next, since we now have the same denominator, then we can rewrite it into a radical form. So 6 will be the new index. 2 squared, this one, and 3 cubed, this one. The next is, we will simplify the ones inside. 2 squared is 4, 3 cubed is 27. 4 times 27 is 108. So the final answer is the 6th root of 108. That's the answer. The next one. Here, 2 third root or cube root of 6 times there, cube root of 12. Actually, that's an easy one. Why? Because they have the same index. So, I'm sorry, I copied the wrong number. It's 4 in the module. So you can write it as 4. They have different indices. So we have 2, 6 to the power of 1/3. The other is 12 to the power of 1/4. So let's check. 1/3 and 1/4. What's the LCD? The LCD is 12. So to make 3 turn into 12, I'll multiply it by 4/4. 1 times 4 is 4. 3 times 4 is 12. For 1/4, I'll multiply it by 3/3. So 1 times 3 is 3. 4 times 3 is 12. Now, Let's have 2 times 6 to the power of 4 twelfths. And the other is 12 to the power of 3 over 12. Let's simplify it. It's going to be 2. 2 is still outside. 12 is now our new index, denominator. Then let's write our radicands. 6 to the power of 4 and 12 to the power of 3. If you multiply that, 6 to the power of 4 is 1,296. And 12 to the power of 3 is 1,728. If you multiply both, the answer will be 2,239,488. This is now the answer. Let's go to the quotient of radicals with different indices. Now, how will you do it? The same with the multiplication. Step 1, we change the radical sign to a rational exponent. Step 2, we express them in similar fractions. Step 3, write it back to a radical form, and then we simplify. Example. Ready? This one. They have different indices, 3 and 4. So you rewrite them first as rational exponents. 2 to the power of 1/3, and the other is 2 to the power of 1/4. Now 1/3 and 1/4. How can we write them in similar fractions? That's 4 over 12, and the other is 3 over 12. Same denominators now. So we rewrite them back to one radical. That's index of 12. For the numerator, that's 2 to the power of 4. Denominator, that's 2 to the power of 3. Next, we simplify the one inside. Same base, we subtract the exponents. Correct. So we have the 12th root of 4 minus 3, 2. This is now the answer. The 12th root of 2. Next, let's go to the next one. How about this? They have different indices. So we write them first into rational exponents. The first is 2xy squared to the power of 1/2. The other is 8xy cubed to the power of 1/3. The next one, we need to express 1/2 and 1/3 as similar fractions. You follow 1, 2, and 3. The LCD is 6. So this is 3 over 6, and 1/3 is 2 over 6. Now, let's write it first. 2xy squared to the power of 2 over 6 over 8xy cubed to the power of 2 over 6. Oops, sorry, on top is 3 over 6. Same denominators, so we can write them into one radical to the power of the 6th root, The first one is 2xy squared to the power of 3. The denominator is 8xy cubed to the power of 2. So the power of a power, we need to distribute this. We now have 2 cubed, x cubed, and y to the power of 6. For the denominator, we have 8 squared. Distribute 1 times 2, x squared, and y to the power of 6. Let us now simplify. Ready? Okay, check on this. For y, 6 minus 6, 0. For x, what's left? Only 1. Then, this 2 cubed is 8, and 8 squared is 64. So 8 over 64 is 1 over 8, right? So over 8. Our final answer is 6th root of x over 8. Now the last one. How do you multiply polynomials with radicals? Step 1. We apply the distributive property or the special products. Step 2. We add similar terms or like radicals. How do you know they are like radicals? They have the same index and the same radicand. And the last one is simplify. Let's start. Ready? The first one. Okay. Multiply these two. Same index. You multiply the radicands. 3x times 12x. Plus this one. No longer a radicand. So you place it outside. 4 square root of 3x. Let us simplify the first one. 3 times 12 is 36. X times x is x squared. Plus 4 square root of 3x. Next, square root of 36 is 6. It goes out. Square root of x squared is x. It goes out. No more left inside. Then we copy the last one. Plus 4 square root of 3x. They are unlike radicals. So this is now our final answer. 6x plus 4 square root of 3x. Now, I'll go to the last one. How can we apply special products on this? Remember, x plus y times x minus y. If both have the same numbers and only the sign in the middle changes, in special products, that's x squared minus y squared. Example, 7 and 7, square root of 5 and square root of 5. Only the one in the middle is different, the sign. So by special products, the answer is square of the first minus square of the last. 7 squared is 49. Now, when a square root is raised to a second power, the square root is eliminated. So we now have minus 5. The answer is 44. This is now the answer. Now, this ends today's lesson. Have a great day, everyone.